Okay, so with logarithmic functions, first we started out with graphing an exponential. Are we all at this point? Okay, kind of, it should be a review. I think all of you are pretty good. Graph the inverse.
Just the opposite.
What are you gonna say?
Is it just use a negative exponent?
No. What do we do with the inverse? We talked about it earlier.
Be -2.
Switch the x and y. Just flip the table and graph those points. Okay, go ahead and do that. So we're going to, for the inverse, flip the table. So we've just swapped the x's and y's, and now graph those points. That's what you can write the function as right now, correct? You just switch the x and the y's. So, does that make sense? You know what we're doing? Okay. You just graph the log. Okay. So that's one method. So that function, instead of writing x equals 2 to the y, you can also write it as y equals log base 2 power to x. Okay. This and that are interchangeable. They're the same thing. Okay. These two are inverses. So so to define a log, you have to use this is different. Okay. So if this is how I write a log, how would I write that as an exponent? Okay. Those are equivalent statements. So where do we see here with the base and the base? That's where those numbers go. Okay. The exponent and then you have your numbers. So basically all you're doing is changing it between two forms. Because they're inverses. They can help you solve one another. Right? Do you know how to solve this? Do you remember?
I was taught but
Yeah, you were.
I don't remember.
Okay, you don't know, right? You can't even touch that in a calculator right now. Your calculator doesn't have a base 2 log. Your calculator log is base 10. Okay? So, but can you solve this one? Yeah, 2 to the what power is 32?
No.
2, 4, 8, 16, y is 5. And while you can't solve this, you can rewrite it. Maybe solve this. Well, we're going to get there. Yeah, that's base E. Yeah, so based on this one, y is 5. Okay. Now here's what a log actually means. If I rewrite it like this, oh, sorry, backwards. What's the answer? No. You know what the answer is. It's 5. Right? So a log is, this is the base. Yeah. What power do we need to get to get to 32? And that answer would be 5. 2 to the 5th is 32. So let's let's write that in exponential form. So basically all we're doing is translating from log to exponent.
What would it be when 25 equals 25?
Right. So you got your base. Some colors here. Your exponent and your number. And you can check that. And it should equal 25, 125 to the 2/3. Do you think you can handle those?
Yeah.
You're just translating back and forth. Okay, based on the definition. I won't show you another one then. Now, same vice versa. Could you write that in log form? Okay, so write in logarithmic form, and I'm going to have you prove it. So go ahead and write that in log form. What you got?
Log base 4 64 equals
Right, because That's 4 to the third power. Okay. So when you're looking at these, you're always trying to get those two numbers to match. Whatever exponent sits here is your answer. Okay. So if you can get the base and that number to match, your exponent is your answer. What power of 4 gives us 64? Okay. Are you with me so far? Oh, okay. Let's try. Let's see. Evaluate. Log base 7, 1/49. There's a couple ways to tackle this one. What power of 7 gives us 1/49? Okay, so some of you know it already. So 7 to the -2 is 1/. So this is 2. So that's one way to do it. If you can reason through that. I had trouble at your age doing these. But that, I don't know why. I just did. Okay. If you can reason through that process, great. If not, here's another way to do it. We can set a method 2. Set it equal to x. Rewrite it as an exponential. Ooh, that sounds wonderful.
It's actually a laugh, and it turned into that.
49 is 49 to the -1st, right? 1/49. If you write it in exponents. Try to match the base. So x equals -2. So this is the same reasoning behind the top one. You're just showing the work more algebraically. Okay. Yeah, and some people get it. This one uses properties of powers, so does that one. They're the same thing, just differently. Just different. So, let's see. I think that's enough. Yep. Okay. Let's get a start on this. So 11/4 part. So, 11/4a, I want to check tomorrow.
I wish you wouldn't. I know I'm taking my homework. And I didn't work on it. You know, I didn't have to do homework. I still haven't done the effort because government was due to you was Friday.
So A, tomorrow? Okay, tomorrow I'm going to show you part B. Down? Oh yeah, you're in the back. Good. So part A is due tomorrow. I want to make sure you got this before we move to solving log equations. But I think you're comfortable with it, just judging by your reactions. We'll make sure.